Hello. In this episode of Yummy Data Science, we are going to be talking about the grammar of ggplot, both conceptually and on a hands-on exercise. To set the context, this is the class that I'm teaching at UMass, Public Health Data Science, and I'm teaching R, specifically tidyverse. And the textbook we're using is Hadley Wickham's R for Data Science. So let's get into it. Here's a screenshot of the data that we are going to be visualizing. And the first thing to ask yourself is this data tidy? Well, what does tidy mean? Well, tidy means that each column represents a unique and discrete piece of information. So you can see that, let's answer that question column by column. So, what are the pieces of information we have? We have a beneficiary ID, which is a patient ID. We have a claim ID, which is sort of their encounter ID. Then we have the length of stay. Then we have the amount charged. Then we have a discharge status. We have the admission status. We have the diagnosis, and we have the description. Okay. So each of these columns stands for a piece of information. The one thing that you could quibble about is that you've got the DRG in numeric form, which is because it is a character, it's a code. So you will see DRG 864. Sorry, I misspoke. I shouldn't have said numeric. What you see it as is a number, but it's really a character code. And then you see the description. So those two columns are really the same information and they're split. So let's not quibble over that. But let's agree that this is tidy data because each variable or piece of information is represented by a column. And then each row is an observation. What does that mean? That means each row of data is its own independent set of data. And that is true because each row here represents a patient encounter. Okay, so now let's go over to the lab in RStudio and we will work from there. Opening up our R project by clicking on the R project file. Here is R. Opened up my RStudio by double clicking on my project file. And now I'm ready to open the script that goes with it. So here is our inpatient 4-viz data. Recall that it is created from Medicare fee-for-service inpatient claims. These are synthetic but realistic claims that were created and put out by CMS. And then on top of that, I used some clever logic and created a file that would be good for visualization. So I've already explained in an earlier video what I'm doing in lines 6 through 14, but basically I am doing some data transformation and I'm making sure I read columns as they're meant to be read. For example, when AID is a character, it should be not read as a number, it should be read as a character. So um, okay. So now we have a hypothesis that the amount charged varies with length of stay and maybe DRG also. So our hypothesis is that as the length of stay increases, the amount charged would also increase. And, we can all agree that that makes sense. But we also think that the amount charged depends on the diagnosis of the person. Because if a diagnosis that doesn't require too many resources, then perhaps the amount charged is lower in that case. So we want to visually investigate this hypothesis. And so we want to get um, into ggplot. And as a good practice, when we visualize something, let's think about visualizing a large chunk of that data because we might fail to see the relationship if we just visualize everything. There might be some outliers. So, what I'm doing right now is I am going to be looking at what are the DRGs, where is my data, where is most of my data here. And I can see that here are my DRGs, and I can see the DRG description, and 180, 181, and 182 are something I'm curious about. These are respiratory neoplasms. Neoplasms is another word for cancer. And MCC means major complicating conditions or comorbidities, and CC means complicating conditions or comorbidities. So here are three diagnostic related grouper codes, and they are all about respiratory neoplasms. So why don't we do this? Why don't we explore the hypothesis that amount charged varies with length of stay and perhaps DRG on these three DRGs? So let's filter our data, and you can see that I'm creating another data frame in patient 2. All right. So now you can see over in our global environment window, we've got two data sets. Inpatient that had 374 observations, and inpatient 2, which is 223. And you can do the math and you can figure out that it is 66 plus 79 plus 78. Okay. Now we're going to get into ggplot. So let's take a little step back here and think about what ggplot is. Well, you're trying to visualize your data, and here is your data. So you've got Bene ID, you've got claim ID, you've got length of stay, you've got amount, you've got these discharge and admission flags, you've got the DRG, the description, and the DRG description field, which is concatenation. Uh, so my data is no longer tidy because, so here is, I'm viewing my data, and it's got a number of fields that I'm interested in, like amount. It's got the DRG field. It's got its corresponding description. And I've created a field that concatenates both of those for visualization purposes. So let's get to it. Now, the data is in a tabular format. So think of ggplot as a canvas, and think of it as a blank canvas or a piece of paper. That's how I like to think about it. On this piece of paper, you will need to know what is up and what is across. So what's your y-axis and what's your x-axis? So that's one of the first things. So on this piece of paper, you will need to tell ggplot what's your y-axis and what's your x-axis. So y-axis, what is the column that corresponds to that? And in our case, y-axis is amount. And the x-axis, what's across, is LOS. Okay, so that's the first thing we are going to tell ggplot. Then we are going to tell ggplot kind of a geometric shape we want. Okay, do we want dots? Do we want little triangles? Do we want little circles? What do we want? Okay, and then we are going to, if for a scatter plot, we're going to give it the geometrical shape. And the way that ggplot works is it works in layers. So it will have, the first will be the mapping layer, what's X and what's Y. Then second layer will be like what kind of geometrical object you want. And now let me stop talking about this and actually get to the code. So you'll see this better. Okay. So with the first invocation of ggplot, all you're saying it, giving it the data. That's it. So let's see what it does. Actually, nothing. You just get this gray. So you get nothing. Because all you've done so far is you've told ggplot what your data set is going to be. So now you get to the stage where this blank canvas or the gray box area you see here, that area, you want to map it and you want to say what is up and what is across. And so here we're doing it with the mapping function. And what we're saying is, what is my mapping going to be? Well, it's an aesthetic of my visualization, and X is LOS, Y is AMT. Okay. So let's see what happens. I did not, as you can see, submit the last parentheses. So I'll do that. Now you can see that I've got amount and length of stay. Um, so the next thing we're going to be telling ggplot is what geometrical object we want. And we've decided these begin with the keyword geom. And when you type it, you'll see that ggplot gives you all these options. And we'll use geoplot. Now this is called adding a layer to your plot. ggplot is nice because it allows you the option to set up your initial mapping and keep adding layers to it. So let's see how this works out. And it's a beautifully designed language for visualization because of the layers and the many other fine characteristics. Now we've got something. We've got a plot of amount by LOS, and we've got each of our records in our data set. Each of the 223 records is a dot here. You can see this clearly shows that there is a linear relationship, although the variation is quite high. Um, So in my comments, I'm saying that this visualization has two explicit dimensions or coordinates. We told ggplot what was up, what was across, but now you can use the color as another dimension or another coordinate. Okay, just as you could do with a piece of paper. And what we are going to do is we are going to use color to bring out each DRG. Okay, so what does this mean? Instead of putting them all as black, we've got three different DRGs. We'll use different colors. So that's exactly what's going on here. So mapping is X is loss, Y is amount, and color is DRG. So we've got three dimensions now. There you go. Now you can see the DRG 180 is red, DRG 181 is green, and DRG 182 is blue. Okay. And if you recall what 180 and 181 were, 180 is respiratory neoplasms with major complicating conditions or comorbidities. And you can see you would expect the reds and the greens to be high. 182 is respiratory neoplasms without comorbidities or major complicating conditions. So the blue is on the lower end, is what you expect. But those are generalizations. You could contest me on that. But now what I want to do is I want to say, okay, can I have a line? I see a lot of variation, like for LOS 5, there's a lot of variation. But if I were to make a single guess for LOS of 5, what would my amount be? So that's what I'm asking in this next layer is I'm asking for a geom smooth, which is adding a linear regression. Because the method is LM, it's adding a linear regression. And that may be a word that you don't know, but just suffice it to say that we are coming up with a line that minimizes all the variance and still captures our data, the trend of our data. So let's do that. Wow. So here you can see that we actually got three lines. Did you expect that? Or not? And you can think about it for a little bit. We got three lines because in this global mapping, the color was inside this global mapping. And the geom smooth, this is an additional layer now, it is referring to the mapping. So if we want to only have a single line across DRGs, then what we can do is move color from the global mapping to geom point mapping. And this is what we've done here. We took the color from mapping and we put it in geom point. So we are saying we want to have the color dimension when we are drawing and coloring in the scatter plot, but we don't want to have it when we are doing the smooth line. Okay, here we go. So now you can see this is a pretty nice linear relationship, even though caveat, there's a huge variance here. So now what I'm going to do is I find it very difficult to read this in scientific notation. So I looked um, at the documentation and I added in the scale of y. And once you get to a point where you can understand this code, you can start. Google is your friend. So is, any um, uh, AI, generative chat AI. So I use Perplexity AI because it gives me the sources. So you can use one of those, or you can read the documentation, or you can refer to your textbook. This is in your textbook as well. So I'm using the scale y continuous, and I am saying that I want it scaled to $1,000, and I want a suffix applied there, which is k. And then I also added in a title, what determines hospital inpatient amount charged, and the subtitle, and so on. And then I'm going to be creating this lovely diagram. Um, and I've got this. I'm going to zoom it out so you can see it in all its lovely glory. Here we go. So this is a pretty decent visualization. Um, So for five, it goes from anywhere to, I think this must be like 50K, goes from anywhere to 20K to maybe 80K. So there's a huge variation. And that makes sense because it's the conditions, the complicating conditions. Now, one thing you will see in ggplot, you'll see short. So people don't put data is equal to, people don't put map is equal to, those are not required. And so you can just have it like this ggplot, then in data is equal to becomes just the data set. And then you have the aesthetic, and you can plus geom point, etc. Now, of course, I've taken off my scales. And another way is that you could do inpatient 2, then with this pipe character and ggplot. And so that's another way of doing ggplot. We're pulling inpatient 2 out, the data set out of it. It's the same. So that concludes our video. See you in the next one. Thank you.